All of the work with standard deviation, standardized scores, and z-scores are all predicated on using the mean as our measure of center. If we use a truncated mean, we can still do those same things because all we've done is exclude some of the data value and do the mean on the rest. So that cuts out z-score, cuts our standard deviation a little because we threw out some of the data. But that's still basically using the mean. So what happens if we switch from using the mean to using the median? Well, median, the median was which of our data values? Or how did we define the median? The middle, physically, right? We put the numbers in order. We put the numbers in order and then picked the thing in the middle. And really, in a sense, that divides the list into two pieces, the high part and the low part. Well, if I chop it into more pieces, just based on order, I can do the same idea. Let's say I wanted 10 groups, 5 groups, 4 groups, 100 groups. I want to take my data set and divide it into more groups. Wait a minute. If I'm thinking of 100 groups, then I could talk about where you are in this list out of 100. Out of 100. I've heard that word before, but in Latin. Out of 100 in Latin. It's on your keyboard in front of you. Above the 5. Percent. Per cent. Centum. 100. There we go. If k equals 100, I call these groups percentiles. I've now set up road marks to make 100 different boxes. If I use 4 of them, we'll call them quartiles. If I use 10 of them, I'll call them deciles. 5 of them would be quintiles. I'm sure there are names for others based on your favorite choice of Latin or Greek prefix. Hexiles or sextiles, whichever way you want to go with that, or duodeciles for 12s, I don't care. These are the ones that get used a lot. Certain percentiles show up as benchmarks when you talk about businesses. You talk about a 95% or a 99%. You talk about the bottom 5 or the top 5 percentage. Well, then you're really talking about percentiles because you looked at a list and you chopped off a set of boxes and said these boxes. Human Resources uses percentiles a lot. The Bureau of Labor Statistics and the Office of Employment Statistics use percentiles. What percentage of the labor market is engaged? All of these things show up in a lot of ways. The most common ones I will use are percentile and quartile. Those are my top 2. There are commands in Excel for both of these. There's a quartile command, there's a percentile command. They're fairly direct. And I didn't put either of them up, so let's find the data file. I'm pretty sure it's in my JD Power file. Here we go. Here's my JD Power file. Let's share that to the Zoom. There. So this data is once again about defects per 100,000, defects per 1,000 vehicles. I've listed them from smallest to largest. When we do the median, we find the middle of this list. If I remember correctly, there were 33. So there is an actual middle. What's the middle number in my list? Careful. Instead of going down, I go up. 33 plus 1 is 34. Do it this way. What's half of 33? But I can't do a half a number, right? So I go up. I go to the 17th number. If you'd had an even number of things, then you would say, oh, 16. But that would have a bottom and up. So I couldn't use the middle being 16. We go between the two. So always add 1 to the number of things in my list. As a matter of fact, there, we highlighted it. Please notice what happens to me sitting in the middle of this page. Q1 and Q3. Beg your pardon?
They're the quartiles.
Those are my quartiles. The first quartile and the third quartile. Now here is the way I remember to do this. We divided the high from the low, right? That yellow box, number 17, that's my division. That means the low end of the list, which is everything above this box, because it's sorted from smallest to largest, top to bottom. So all of these up here, that's my low half, my small half. How many numbers are in that half? If I don't count the yellow box, there are 16. Find me the median. In a group of 16, I have 16 things, where's the middle? How many should be in each half of my list if there are 16 things? There should be 8 in the low and 8 in the high, right? Which means I'd be between the 8th and the 9th number. Add 163 plus 165. Divide by 2. What does my quartile 1 say? What the? I mean, well, you just said 164, man. Why is it different? We made the conscious choice to say that in the low half, there were 16 numbers.
You have one for just the same.
Unfortunately, no. It would be nice if I could do the same thing. What Excel does is it gives me the choice as to whether or not I should include the middle as part of that half. So instead of saying there are 16 numbers in that half of the list, it says there are 17 numbers, which means the middle is the 9th number, which is exactly 165. That's called an inclusive quartile because it included the median. The one we came up with using 164 is the exclusive quartile because it excludes the median. If the median is part of the data set, we have an odd number of things, then we can do it either way. This makes me crazy. I almost always tend to think of exclusive rather than inclusive quartiles. It's not going to be a very big difference very often. 164 versus 165 on a list that is in the hundreds isn't really that big a deal, is it? What's the error? Oh, it's one part in, oh, we went from 140 to 265. It's a very small change. On page 124, we have this picture. This is what my quartiles are doing. They are the dividing lines between 25% of the data. I had 33 data items. What's 33 divided by 4? 8 and change. The and change is the part that makes me crazy, right? If you say, well, there are 33, so the middle should be one of the numbers, then that would be this. And then you could say, well, I have 16 here and 16 here because I put a box, one of my numbers right here. But you could just as easily count that middle here. There are 17 down there. There are 17 up here. At the bottom of this page, we see how it depends on the number of things in our list as to whether the quartiles are between values or hitting values based on how many numbers are in my list. It is your choice as to whether or not to do inclusive or exclusive quartiles. Excel gives me the option. If I go back to that picture the spreadsheet we were just looking at, you'll see the command there simply says quartile. That's the old version. It didn't give me a choice. But now there are actually two quartiles expressions. One says quartile.exe. That's the exclusive quartile. The other says quartile INC. That's the inclusive. Notice the only differences are here and here. The median stayed the same. You're measuring the middle. But when you measure the second middle, you have to decide what you're doing with that first one. But notice there are really 5 numbers here. Even though I think about quarters, there are 5 numbers. Why are there 5 numbers to make 4 pieces? This is a sneaky idea. I want you to make a fence. Fence sections are 10 feet long, and you need a post at each end. If I want you to make 40 feet of fence, how many posts do you need? Because you need 1 at the end and the beginning, and then 1 in between each section. I need a low and a high each end. And then I need the middle, the 25% mark, and the 75% mark. So when we go to give it the quartile command, which is up there, quartile.inc or exe, you can tell it which one you want. Q1 is quartile comma 1. You tell it where the data is, and then you put a comma. Quartile 3 is number 3, but the max is quartile 4. The median is quartile 2. So you use the same command for all of these if you want. Same thing with percentages. Percentiles can be done in a 100 group. How would I figure out what percentile I need? Well, I want to make sure I get more than whatever number is in that spot. Let's say I had 1,000 numbers. I put them in order. Then you would expect the 50th percentile to be the 500th number, right? I need to go to the next actual value in line. Let's say that 500th number happened to be 500. But so was the 501st number. And so was the 502nd number. And so was the 503rd number. You actually have to go up until you get to the next value. And then you can say, hey, 50% of my numbers are less than this value. It's a strict inequality. There is a formula in the text that says for percentiles, turn off the share so I can show you what I'm writing. If we only had like 9 numbers and I asked for the 30th percentile, what's 30% of 9? How do you get to the 2.7th spot? You can't. But you can use this idea to get between the two, right? You can go 7/10 of the way, or 3/10 of the way, right? Because 30th percent between the second and third number. So you would go between the two numbers, and basically you're drawing a straight line between the two numbers and going partway along the line. It's called interpolation. Most of the time, it's beyond what we'll be asked to do by hand, but it does show up in the Excel results we get frequently. And as we see in our JD Power data, there at the bottom here, it says do the A column. What are the numbers in column A? They're just the numbers from 1 to 33. So 90% along that is not one of the numbers, is it? Because 90% of 33 is 29 and change, 30 and change. So we have to step along the way a little. And that's why these are not exact values when we do percentiles, because they're interpreting between the two. You'll notice over here on the right, I have a box plot. What the hell's a box plot? There are 5 horizontal lines in this plot. What are those 5 horizontal lines? Where did those 5 horizontal lines come from? Yeah, but what sections? How do I know those sections? Why are they all different sizes? What are they coming from? Exactly. In order from bottom to top. Low, quartile 1, median, quartile 3, high. The box, the bottom of the box is the first quartile. The line in the middle of the box is the median. The line at the top of the box is the third quartile. That's that central box. Q1, median, Q3. The bottom bar is from the quartile down to the low. The top bar is from the third quartile up to the high. You will often hear this called a box and whisker plot. We're going back to the cat cafe. There's an X floating in that box. It's kind of hard to see at the moment. You see the X? The X happens to be where our average is. So you can see this data is skewed. It's skewed high. because the mean is above the median. And that long whisker at the top is evidence of that skew out to the right side. The height of the box is an important idea. That's the difference between Q1 and Q3, right? In our, I don't care whether you use the inclusive or the exclusive, if you subtract Q1 from Q3, you get this thing called the interquartile range. That's the height of this box in whatever units we're using. Right here, I've labeled it IQR. Interquartile range. It's the height of the box. But this actually gives me more information about outliers. We decided what made an outlier based on z-score, right? What made an outlier based on z-score?
If it was outside, it's either 2 or 3. If it was inside or outside, either -2 or +2.
Was it 2 or was it 3? Because you gave me 2 numbers. It was 3 for the outliers. It was 2 for the unusual. But what I'm going to use is I'm going to use this interquartile range. And I'm going to say that. That helps me figure out what the outliers are. Let's take that. Go by half again that. And we'll look above the third quartile or below the first quartile. There's a formula way to write this. The interquartile range IQR, that's quartile 3 minus quartile 1. I'm going to take Q1 minus 1.5 times this. Anything below that is an outlier. I'm going to take the third quartile and I'm going to add this. Anything above that is an outlier. So what we're really saying is that the interquartile range is kind of like 1 standard deviation down and 1 standard deviation up. And we're thinking that the weird stuff is at 2.5. We're going to call these fences. So this is the low fence, and this is the high fence. And again, if we go back and look at that JD Power spreadsheet, wrong button. We see the fences are labeled. Notice the ha on my data set is 265. What's the high fence? Depending on which quartile you used, it could be different. If you use the exclusive quartile, it's 270. 271.5. If you use the inclusive quartile, it's 262. That means we have an outlier, depending on which quartile we chose. The low fence, again, depending on quartile choice, is either 99.5 or 106.5. But the lowest number in my data value is 139. So I don't have any low outliers, but I have at least one high outlier if I use the inclusive quartiles. Sneaky. Questions? depending on your scenario. As I said earlier, the Bureau of Labor Statistics uses quartiles. They talk about the growth of unemployment based on pay quartile. They talk about it by sector. Oh, we're looking at technology jobs. We're looking at conservatory jobs. They go through all sorts of different job sectors and they look at growth or loss by sector. And they look by quartiles within that. Well, the lowest quartile pay, the lowest quartile values increase. That means pay must be going up. Q1 went up. There is a way to rearrange this box plot. So instead of going up and down, it goes left and right. On our graphing calculators, when we put in numbers into our lists, remember our lists? We had all this data, right? When I put my numbers into my lists, above the y equals button, it says stat plot. If I hit that, there are options to do plots here. You can do scatter plots on the calculator. We talked about scatter plots last chapter. We'll talk about it again in about another 10 minutes. But if I go to this first plot and I hit enter, look at that. There's a box and whisker plot available to me. And then it asks, where's your data? Well, my data is in list 1. If your data is somewhere else, tell it which list it's in. And then you can create marks. Now I have this still turned off, so let's turn it on. Why don't I see anything on this picture? Because my data is fairly big and my window isn't. I have to go up to much larger numbers to see my box plot. This is the quiz data we were looking at on Monday. I think it was Tom's quiz data. There were only 5 numbers: low, quartile 1, median, quartile 3, and high. I got all 5 numbers right here. And again, I see a really big interquartile range. The box is really wide, isn't it? The whiskers are pretty small. So I would doubt there would be any sort of outlier in this. There's a really big spread, like our standard deviation, right? I can see it as the gap between the quartile lines. Questions? There's a bunch of box plot examples here on page 127. There's this interpolation method explicitly written out on 126. There's a typo here. They did the inclusive, not the exclusive. That's okay. But on the previous page, they mentioned that they're doing the exclusive version. So they typoed something in here. These are not right based on the exclusive data. They're on the inclusive data. If we want the exclusive, they should be the numbers. That's why I put the fences in the spreadsheet so that you'd have them both ways. Please notice, if we do have outliers, it is quite often considered reasonable to remove them from the whisker. So this 2018 box plot here shows me the 5 lines But then it says, hey, wait a minute, these numbers were so far out of the range of what we think is appropriate, they're beyond our fence, that we're going to take the number that's inside our fence, make that the high, and leave those as disconnected outliers. I don't like doing that as much because I think you want the highest number, you want the highest number. Worry about outliers some other way. Questions? Because these are all the same kind of data, we can compare them together, defects per 100 vehicles. We were looking at the 2022 data in our JD Power file, but here's 2022, 21, 20, 19, 18. We see dramatic differences year over year, right? Defects per vehicle is technically getting bigger. And this is the part that bothers me again. You'll notice the years are not in ascending order here. 2018 should be on the left, and they didn't put that. They put 2018 on the right. I don't know why. Excel hates me. This is what it does. It's a personal opinion. Questions? There's one other number we use frequently, and that's the average of the quartiles. Q1 plus Q3 over 2. Just add them together, divide by 2. This is called the mid-hinge. We call it the mid-hinge because it would be where you would fold the box and the edges would line up with each other. It's the middle, the top of the bottom of the box. It's not necessarily where your second quartile is, your median. It may be somewhere different. That's the part that's weird. We saw in these scores here, this is our set of quiz scores, right? First quartile is 40, third quartile is 75. What's the average of 40 and 75? This one type. Halfway between 40 and 75. Which is way lower than 70, isn't it, right? So my median and my mid-hinge could be very different. But again, this reflects skew. That tells me, oh, my data is more up here if the median is that far above the hinge. There's more numbers up here than that makes sense. There are 3 numbers above the mid-hinge. There are only 2 below it. Now, this is a small data set. So in larger data sets, we can look at what that means in general. But when my median is to one side, I have a skew. And it's in the direction of the hinge. We just said our hinge was above, right? Our hinge was above the median. That means there's more stuff on the right than there is on the left. More questions. Ask me more things. Ask me anything. Okay. We talked about scatter plots. There is a way to do a scatter plot on here. If I set up a scatter plot, it asks me for two sets of data, X and Y. You already did this. Remember our two stock prices? The Lona and something or other, began with a Z. I've forgotten what the name was, but we had a D and a Z stock, right? We had to make a scatter plot. Close the JD Power. Close. Here we go. Open this one. What we have here is a data set comparing home prices with the size of the house. I've got 20 houses. The left column is the number of square feet in the house. The right side is the number of thousands of dollars that this house sold for. I don't know where we are, but there's some expensive homes here. A question to you. High price, size of house. Are those related to each other? Say that again, Emily.
Should be.
Should be. They aren't necessarily, but they should be. So how can I tell? Well, that's what a scatter plot does for me. It shows me that relationship visually. So I create a scatter plot of these pieces of information. Insert. There's my scatter plot right there. Option number 1, bang. Price was the second column. It became the y-axis. If you want to switch them, you could do that by editing the data. See how it says switch rows to columns right here? Or you can change the X and the Y values right here. You can adjust your data. I'm not going to do that at the moment. You right-click on one of the dots, and one of the options is select data. So it looks like the more square feet go to the right, the more price go up. A positive, fairly strong. Fairly strong. Well, they're pretty close together, aren't they? The closer together the data is, the less my relationship, the less difference there is in my relationship, the stronger it becomes. The further apart the data is, the weaker my relationship is. What I could do is I could look at variance. We did variance already. Variance went with what? This was Monday, maybe even Friday. When did we talk about variance? The variance was the standard deviation squared. Or the other way to say it is the standard deviation is the square root of the variance. So we had this idea of variance. But what I can do is I can actually say, instead of taking just the X values and looking at the variance within them, or taking just the Y variables and looking at the variance within them, I can look at the product of the two. This is the weirdest unit I'm going to come up with today. I'm going to talk about the unit square feet dollars, because I'm going to multiply the units together. The formula for this takes the variation, that's the number minus the average in the X's, and multiplies by the number in the average difference in Y. It's an atrocious looking formula. Called covariance. Hey, we're not just looking at one variation, we're looking at them together. So this is for a sample, and this is for a population. That only changes what you're dividing by. We're never, ever, ever going to do this by hand. Not ever know how. But if I take that covariance, I can create correlation. Now, the word itself is the important part. Correlation. Are they related to each other? We did this already. In Excel, I have to do it from here. I have to do it from here. If we right-click on the data, I can create a trend line. There's my trend line. That's the line that fits the best. We'll define what that means more precisely later. But down here at the bottom, it says, show me the equation. Show me the R squared value. That R squared value, that's my correlation idea. It's the product, covariance divided by the individual variances. It's an atrocious number. But it's always between 1 and -1. When it's positive, when it's negative. Positive, we're going up as we go from left to right. When it's negative, we're going down as we go from left to right. The closer R is to 1, the stronger our relationship is. R is called the Pearson correlation coefficient.
Square one, always positive.
It will, but I then have to look at the picture and say, when I take my square root, should it be the positive square root or the negative square root? What is the square root of 0.6952?
The
You see how I typed in this command and it started to highlight those in 2 different colors? It's highlighted the X values and the Y values. I'm asking it to correlate, C-O-R-R-E-L, correlate the X's and the Y's. Give me that number again, Emily. .834. And that's the square root of this R squared, right? That's our covariance and correlation idea. For scatter plots, this is incredibly useful. If you do a scatter plot on your calculator, it will do R and R squared as well. An important note. R is a measurement of the linear behavior between my data sets. Whoops, I hit a button. That's not the thing I want to do in this class. Let's get rid of that. That's next class. Here are 6 different scatter plots with their respective correlations. If you go to the Wikipedia article on correlation, it will show you 23 different graphs, all of which have a correlation of 0, some of which are actual pictures, like a smiley face or a dinosaur. But because they're made out of little dots, the little dots actually don't have a linear relationship, and correlation only measures straight line behavior. Questions? We did histograms, right? And the thing about doing a histogram is it grouped our data. Well, sometimes instead of having access to the original data, I only have access to the histogram. What do I do if instead of having all the data, I only have the histogram or the frequency distribution. Here is, again, an ugly looking table. Page 137. I don't know what the data is, but here's the frequency distribution. From 60 to 65, there were 6 numbers. 65 to 70, there were 11 numbers, and so on, right? For a total of 47 numbers. I would like the average of these numbers. How am I going to get the average of these numbers? I don't know what the individual numbers are. I have 6 numbers between 60 and 65, right? Let's assume that they are equally distributed between 60 and 65. Then I would put most of them in the middle. What's the middle? 62.5. So I will say that instead of having 6 different numbers between 60 and 65, what I actually have is 6 copies of 62.5. And instead of having 11 numbers between 65 and 70, what I have is 11 copies of 67.5. This is a radical simplification of the data because they might not be uniformly distributed there, right? They might not be spread out evenly. They might be on one edge or the other. So this is going to be an estimate at best. So what's 6 times 62.5? Well, I'm going to do this for every one of these 2 columns. I'm going to multiply the frequency, F, by the middle, M. Add all those up and divide by 47, because there were 47 pieces of data. This is my guess for the average. It's not exact, but if all I have is the frequency chart, the frequency table, or the histogram, I can do this. And it'll be really damn close. How close depends on how big the ranges are. The smaller the ranges, the more accurate I'll get. Big ranges like 60 to 80, well, then I could have some problems. I can even go so far as to do all of the standard deviation calculation the same way. Subtract each one from the average, square it, multiply by how many there are, add them up, and take the square root after dividing by n minus 1. Not doing this by hand. I'm going to follow this table. I'm going to do it all in Excel, which is why we have an example. Here is problem number 53 out of the textbook on page 138, where it tells me this information. Between 2 and 6, there are 7 numbers. Between 6 and 10, there are 12 numbers. 10 and 14, there are 3, and so on. 25 numbers. M is the middle, halfway between 6 and 2, halfway between 6 and 10, and so on. And there's exactly the same setup as that table on page 137. Sorry, 136. No, 137. I was right the first time. When you do this, you could even do coefficient of variation because you have a mean and you have a standard deviation. So once you have all of this information from Excel, we can then go on and read with the same ideas we've already done. I am not going to make you do this by hand. All of this, you should adapt these examples and follow the ones that are given in the text. If I do them by hand, it's just calculator push after calculator push, and it's nauseatingly tedious. This again makes the assumption about the data, which is not always 100% accurate about its spread. And we could use these ideas to talk about shape. There is another section in this chapter called skewness and kurtosis. Kurtosis means twistedness. We're not going to go into that much detail. If you really want to measure skew and kurtosis, we cheat and go back to descriptive statistics because it makes those for us. This is the end of chapter 4. This means two things. One, you have a homework assignment due Monday. And that's 3 chapters, and that's a lot. So a week from today is our first exam on those 3 chapters. There's a study guide up on Canvas. If you've got questions, you should read through that. You should read through the information sheet above that study guide, and then you should come talk to me. Come to my office hours, send me emails, ask me all the questions you've got. I will see you all on Friday. Have a wonderful rest.